It's 9 o'clock. Let me get started. What I wanted to talk about today was, like I've talked about in the meeting, it's the combination of two sets of programs. One is a group of programs that fall under the Hamlib heading, and the other is a program called Node-RED, which is basically graphical programming language. And between the two of them, it lets you set up what they call dashboards, what I'd rather call a control panel, because it's really for you to control the radio and the feedback. And you can do in software what you'd otherwise be doing in hardware. And a good example is this box is a box that we built a couple of years ago to control the satellite antennas. So the satellite antennas, sometimes you're going up on 2 meters and down on 70 centimeters, and sometimes it's the other way around. And what this did is sniff the frequency being set to the transmitter and then apply some logic, which is what's in here is an Arduino. So it was a program written in C that basically said, if the uplink frequency is 432, switch the antennas this way by relays in the box. And if it's the uplink frequency is 2 meters, switch it that way. And so you can see all the inputs into this thing. We had a CAT input coming from the radio. We had a push to talk input coming from the radio. We had power going in for, let's see, this is power going into for the 12-volt relays. This is the output for the 12-volt relays. This is the input to the Arduino, because the computer was also controlling the Arduino. This is power input to the Arduino. This is a USB input to the Arduino. And I don't remember what the hell this is. Okay, but these were all cables coming into this box. This is a replacement. Okay. And what you can see on it, this is a Raspberry Pi. There are no connections to this when we put it into operation. This is 12 volts in, and this is the connections to the two relays out. Everything else is wireless, or it's built in, or it's logic that we've built in here. And what's in here is basically a Raspberry Pi, which is underneath. Everybody knows what a Raspberry Pi looks like. And a relay board, which is mounted on the top. I'll pass this around, be very careful with it, not hold it in. And the relays on the top are controlled by logic pins on the Raspberry Pi. And that's what controls the relays. So by extension, we are programmatically controlling these relays, which means you could control anything that you can control with a relay. So you're building a sequencer, you're building an antenna switch or anything like that. All of that stuff could be done by a device like this. Okay, and I'll pass this around if you want to look at it. So that's kind of the idea behind a lot of this stuff. We were able to take a lot of the hardware and C programming logic in this box and write it all using Hamlib and Arduino and Node-RED for this box. And it's a lot easier too, because for this one, we have 3 buttons on here and an LCD controller. So you want to have a button, you got to take a button and you've got to connect it up to your board, and you got to drill a hole in the box or 3D print it and mount it and stuff like that. And then if you want a different configuration, you got holes in the box already. But with your programming dashboard, you just throw it up on the screen. And if you want it to be different, you just change it. So like in the design of this thing, I had like 3 different or 4 different user inputs, as I decided, well, that doesn't make any sense. Let's get rid of it, and we didn't have any hardware changes to make. It's all in software. So that's kind of the use case for this kind of stuff. And you could build a device. I was talking earlier to the people who were here early, where with one button you could press the button and it'll set your radio to 14250 on 20 meters, set it to upper sideband, turn the amplifier on and set the amplifier to that frequency, and rotate your antenna to the east. Okay, because all of that kind of capability can be implemented in these programs. So that's why I really like this stuff, and I think it's really simple to use. So let me start with the Hamlib library. Hamlib is a collection of programs, and each of them controls some type of a device. And so I'm going to see if I can zoom. I don't know if I can zoom this out a little bit. But I'm going to go real quickly through what they are. We're going to use a Hamlib program called Rig Control. And Rig Control controls your rig. It talks to your radio. So you can send the command like Rig Control F 142.050.000, and that would set your radio to 145 to 142.05, or it would set your radio to upper sideband. That controls the radio. I'm going to skip through this because I'm going to show you more detail on it. Then there's a program called Rotate Control. The Rotate Control is pretty easy. It just tells your rotator which direction to turn, or it can ask your rotator where is it aiming. So you would give it a M16, 60 command, and it would rotate the rotator. Okay, that's pretty simple, and it works for azimuth and elevation too. So if we wanted to build a Hamlib library where we were controlling the azimuth and elevation rotators, we could do that. Going further down here, there's an amp control program, which I haven't looked at. I haven't looked at anything below these, but there's an amp control program that talks to an amplifier. The programs that end in a D, you talk to them through a TCP port, which I'll talk to you about in just a second. So there's Rig Control D, Rotate Control D, Amp Control. There's a Rig Mem program that will talk to the memories in your radio. So and I haven't messed with any of this stuff, but presumably you could build something that would program or change around the memories in your computer. There's a Rig S meter program that if your computer supports remotely reading the S meter, it could query the S meter. Okay. There's a Rig SWR program that if your computer remotely can report back the SWR, it will report back to your program what the SWR is. And then there's a couple of others that combine some of this stuff. So there's a program that will use the combination of sending a frequency to the radio and then recording SWR. It basically builds in its own SWR meter in the fact that it'll set the power level of your radio low, transmit on a certain frequency, read the SWR, kick the frequency of the radio up, read the SWR again, kick the frequency of the radio up, read the SWR again, and it'll basically go through and do an SWR plot using your radio and your antennas. There's also one that uses the S meter where it will rotate the antennas around and read the S meter and basically give you a plot of what the noise sounds like in different areas. And what I'm interested in doing is taking that and combining it with Rig Control and basically saying, okay, set the radio to 2 meters, spin around, set the radio to 70 centimeters, spin around, set the radio to 220 and spin around, and do it every hour for the next week. And then we know when we got a noise plot in the whole area. So that kind of stuff is capable in here. The other thing that these things do is they provide what I call a level of abstraction between your computer and the radio. And what I mean by that is if you've ever gotten into looking at what the actual CAT commands are for sending data, commanding the frequency in a radio, by sending the actual CAT commands that the radio wants to read, they're a pain in the ass. And they're different between Yaesu, ICOM, and stuff like that. This takes away that difference. You basically start Rig Control by telling it what radio you're using, and the commands are always the same. A lowercase f always asks for the frequency, and uppercase F followed by a number always sets the frequency. And it takes care of sending those commands the right way to whatever radio you specify. So the cool thing is if you write an interface like this for the 991, and I wanted to plug this into my 7100, all I have to do is start Rig Control with a different parameter. And all those commands will automatically be transferred. Okay, so that's the really nice thing that I like about this, is it creates a level of abstraction between the user interface and the radio itself. It makes your program radio agnostic. So I'm not going to show you how to install this stuff because you can Google that. but it runs on Windows, which is what I'm running it on today. I'm running all this stuff today on my laptop. It also runs on Linux. So for this application, we're running Hamlib on the satellite PC in there, and it's talking to Node-RED running on a Pi. Okay, so Node-RED's running here. We did a Pi installation of Node-RED. We did the other installation on the other PC. So it doesn't matter. You can control devices with the computer you're on, or you can control devices with something that's hooked up anywhere. You know, and if you can talk to something on a network, it doesn't matter where you are. I could have a Node-RED thing running at home and connected to the VPN in the clubhouse and control this device. Okay, it's just all done over a network connection. So let me talk about how you start Hamlib. This, first of all, well, here's a recontrol. And I guess
you might mention that WSJTX, the default is using the Hamlib library.
Okay, I didn't know that, but that's interesting. Control Plus will.
Yeah, so it controls the radio and everything.
Yeah, there are a lot of third-party products that depend on Hamlib.
Yeah, yeah.
And now,
so if I'm starting,
might include remote Hamlib, or remote. Well,
yeah, all right, or yeah, they all do.
Right.
Yeah.
So this is how I start rig control. This is actually a Windows batch file that I've set up, so it's got all the commands in it and stuff like that. And the command is rigcontrolD.exe, and the first parameter -m is what kind of radio am I talking to? And I'll tell you how you find that in a second. But a 1035 is a Yaesu 991. The second -s is what speed is the COM port that I'm talking to? Because when you're talking to a radio through CAT, you got this radio connected through a USB port to your computer, right? That's the way you connect a radio to connect through CAT. And there's two parameters that control that. One is what COM port are you on? And the other is what the speed of the COM port is. And you have to do that anytime you're using CAT control on a radio. You have to do it in FT8. Yeah, you have to do it in PST rotator for satellites. So how many people know how to tell what COM port your radio is hooked up to? Okay, very few. So the way you can tell is in the device manager. And I'm going to come down here and I'm going to look at the COM ports. And this is the only thing I've got hooked up to my computer now, which we're lucky. If you go in the other room, there's a whole bunch of devices hooked up, and you got to figure out which one's which. Can I zoom this at all? Don't think I can zoom this. And so what you could see, if you can see this, is there are two COM ports here. One is a enhanced COM port, and the other is a standard COM port. COM8 is the enhanced port. COM7 is the standard port. It's always the enhanced port.
Yeah, okay.
Okay. So that's the one, that's the port on a radio like this, and my ICOM is the same way. That's the CAT port. That's the port that's going to allow you to talk back and forth to the radio. The standard port is just for push to talk. And that one just flips the DTR or CTS field on the RS-232 output to 1 or 0. That's like for creating remote push to talk. That's for like keying an amplifier or something like that. There's actually no data that goes back and forth with that. So that's half of this. How do I know that it's COM8 here? This is how I know that it's COM8. Okay, from device.
Are those
device
two
manager.
adjacent COM ports?
Yeah, it's COM8 and COM7, and usually it will be. If you're doing fancy stuff with COM0 or something like that, just be aware that I've had a situation where COM0 has assigned a port, the same port as a piece of hardware. And that drove us nuts for a while. So, but in this case, we're not doing anything fancy. This is just plugging radio into a computer, and this is what we've got. So that's where this parameter comes from. This parameter is set in the radio. And if you're using the COM port in the radio, somehow there's a setting in each of your radios, and it's all different depending on what radio it is. In this radio, it's like menu option 12, and it's entitled RS-232 speed. And it can be anywhere from 1200 baud to 57,600 baud. In this case, this radio is set to 38,400. That's just where it's set. There are two different baud rates in most of these radios. One is the connection speed to on the COM port, and the other is the packet radio speed if you're sending packet, and that's either 9600 or 12. Don't get them mixed up.
You won't see 38.
You won't see 38.4 on the packet.
Yeah.
Okay.
Nice.
Right. So that's how you set these parameters. Now, how do you know what kind of radio you're in? Well, let's see. Where did I do that? See if I can swing. Yeah. Recontrol -L right here. Give it the recontrol -L command, and that is listing all of the different types of radios. All right, so I go down here and I see that there's my FT991. It's a 1035. You'll have to do that to figure out which radio you'll control it. Okay, because that is this parameter. Okay, so now you know how to get to all three of the things that you need to start rate control. Now there's other options you can put here. I'll tell you what the V thing is in a minute, but there's other options you can put in here, like avoiding handshaking and changing the port addresses and stuff like that. So there are other options, but I didn't need them. I'm using the standard everything after that. The -V option is verbose, which is basically when you run the program, how much do you want it to feed back to you? How much do you want it to tell you about what's going on? And the more V's you put there, the more verbose it is. So I've got it set to V, which means just basically keep pounding me with everything that program is doing. That's useful for debugging because if you're talking to the rig control program, you may want to see whether the rig control program is responding to your command or not. That's kind of helpful. So I default to this, but once you're running, you would probably could turn it off because once it works, you don't need to see everything it's doing anymore. And I set this up in a batch file just so I can run the batch file, so I don't have to type all this command in here. So I did that, and that is in.
So where do you get the documentation that explains all of that?
What I'm going to tell you is Google it. Okay, and the download and installation instruction. I don't want to spend time on how to install this thing because it's going to be different if you use one of these or this and all that kind of stuff. So hey, Len. So
It's all online.
yeah, it's all online.
You go to the Hamlib, website.
Yeah, and some of it's on GitHub and some of it's, depending on what you're installing it on. So this is the mistake that I usually forget, the mistake I usually make in these things is you got to run the rig control program and have it running in the command window before you use rig control. Okay, you got to run Node-RED command program and have it running before you use a Node-RED. I can't tell you how many times I've gone in and tried to open the Node-RED interface and it doesn't work. It's because I forgot to start the damn program. So stick that in the back of your mind that you've got to do this before you start up. Now, for this thing, I've got Node-RED starting automatically. Okay, and in the other room on the satellite computer, once we got up, I'll have it start Hamlib automatic. But for this, I'm just fooling around, so you got to start it manually. So this is the command. I ran the batch file, and it gives a rig control -M dash. This is the command I just showed you, and here's how it comes back. Okay, it's found that it's a 991. It's got VFO. It's got VFO mem. So it's going in and checking to see what commands it's able to do. I'm not sure what it's doing in here. I don't know why I was trying to open COM8. But
It's probably where the audio is.
yeah, it could be. It's I think it's going into the radio and finding out what the radio can do.
Put it this way, if you have an let's say ICOM, standard ICOM here, 7300, it's got a single cable that handles both the audio and the digital signals. There, you'll find that 7 and 8.
Right. So this is basically rig control starting. So rig control is now running. And the commands for rig control, I showed you some of them here. If I send it an F, I can find out what frequency the radio is set to. I send it an M, it'll give me the mode. Well, how can I test that? You don't have to know this, but it's useful to know this. There's a program that we use called PuTTY, which allows you to talk back and forth to different devices. We use it to talk to one of these things. And it basically is talking to Hamlib over the TCP port that it's using. What do I mean by that? The TCP port. I don't actually know what a TCP port is, but I know that if you give it an IP address and you give it a port address that's specific to a particular program, those programs can talk to each other. And the IP address can be on your local computer like it is here, or it can be on a remote computer. So those two combinations, the IP address and the port address, let me talk from this program to the Hamlib library and send it commands.
So that allows you to have multiple instances, right?
That's a big deal. Yeah.
You can test that with ports.
Yeah, yeah, that is a big deal. So, and the reason that's a big deal is if you work with COM ports, you know, you can only have one device hooked up to a COM port, right? But TCP ports, it doesn't matter. You can have multiple devices talking to a TCP port, and we're going to use that here. Okay, we're going to have several different commands going to the same IP port. Okay, so the default port for rig control is 4532. I know that it's in the documentation. I could have changed it if I wanted to. Why would I want to? Suppose I want to control two different rigs. All right, then I'm going to run two copies of rig control, one on 4532 and the other on 4540. So I can talk to each rig separately. Okay, but in this case, I'm just talking to port 4532. So all I'm doing now is setting up a program that lets me talk to that radio, and I want to make sure that when I send it a command, it comes back. So this is like the simplest interface. This is not something I'm going to do development on. This is just testing to make sure I understand what the hell's going on. And for example, when I was trying to program this to send a mode command to the radio, it wasn't working. I was sending M USB and it didn't work. And through going through this and looking at the documentation, I realized that you also have to send a passband. So M USB 2400 works, but M USB doesn't. And I figured it out from doing this kind of thing. So here I'm just going to go. And I opened up went through that too fast. Let's just go through it again. So it's yes. PuTTY. I set up a standard connection to this. This is connecting to 192.168.50.78, which is this computer. Okay. I could also say localhost here, right? You guys know what I'm talking about, or you want me to talk about this? Okay. Set switch. Telnet 4532. Okay. So this computer has an IP address, and that IP address I can get to some Wi-Fi. John, you may have to help me with this.
Properties.
Yeah, probably.
Where do you look?
Here we go. 192.168.50.63 is what this computer's address is. Okay, so if I want to talk to this computer, which I do because I've got Hamlib running here, this is the address that I need. I'm going to go here and I'm going to go 192.168.50.63, port 4532, held that connection and not working. I've done something wrong. Sorry, I thought I had this set up before.
I mean, it's echoing back, right?
Use local host and 532.
Yeah, well, in case of Wi-Fi, it's not like
On your network.
Yeah.
whether it's your own.
If you put like 1.7001.
Yeah, you can use local host or you can do that too.
Yeah,
There we go.
Yeah.
Okay. So I sent it an F and it came back with 147 179,300. Is that right? See the radio set to?
Yep.
Okay, so we know that's working. And if I give it an M, it's coming back with FM 1600. There's a radio set to FM. Yeah. So now we know we're talking to this thing. Okay, we know that it's we got our IP address right and the frequencies are right and the rig control set right, because if we had the wrong COM port or wrong speed, it wouldn't work.
And this is the putty program?
This is PUT.
Yeah, okay, that's Windows only, is that correct?
No, it's
no,
Buddies.
PUTTY's universal.
Okay, thanks.
it's a telnet client, so if you just,
Okay,
If you're in
Telnet and SSH and all that. That's why
Yeah.
we use it. We use it to talk to Raspberry Pis when we're programming.
right.
That's why I've got it on here. So now all we've done is we basically verified that rig control is working. We're done with Hamlib. Okay. Now I'm going to go talk about Node Red. Node Red, it's probably easier to show it to you than
And
to
the
you.
background screen just changes to red.
It's not. That's not it, John.
John.
That's not it. That's not
You
it.
made it funny, John.
That's not it. Okay. Node Red basically allows you to program using these things that are called nodes and just connecting them together. So this could be a statement. If I was writing this in C or Python or something, and I want to read the frequency. So I could say, set command to F, read the TCP, print it. That would kind of be the programmatic description of this. But here you can just take different functions and connect them together and pass information. So let me take the easiest one. This is an inject node. And what it does is it puts data into a flow. So this is basically where we want to take an F command and we want to send it to something. And the simplest thing I'm going to do here is I'm just going to take an F command and print it out. Okay, without even doing anything else. So this is an inject node, which is how you start a process. You almost always start with this. And if you're used to having variables in a program, which you usually are, it has a variable called message payload, which you really don't care about because that's the only variable that's used in most cases. And in this case, it's defaulting to a timestamp, which means it would send the time. Well, let's just stick with the timestamp. It's also setting a topic, which I don't care about, so I'm going to delete that. And this is going to happen every time I push this button. Okay, every time I push this button, it's going to run. But look down here where you'll see a repeat. And you can see a pull down where I've got an interval or specific time or things like that. We're going to use that later because if you want to read the frequency of the radio, you probably want to read the frequency of the radio every second. So a little later on, we're going to set this inject node, not just to go when I push the button, but to go every second and over and over. What's the frequency? What's the frequency? What's the frequency? What's the frequency? Oh, there's a frequency. Put it down. Okay, so I'm gonna create a node here, and I'm gonna give it a name. Right. And the other thing we use is the debug node, which basically says, what's this thing outputting? What are we getting out of this? You can see up above here, I'm going to actually send it to the radio. That's what this step is. But for now, let's just go do this. We're just going to take this thing, which is going to give us the timestamp, and we're going to see what it is. So this is our first program. This is like set X signal to ham radio, print X. That's kind of the equivalent of this in programming. So I set these guys up, and then I have to deploy it. This is basically compile it, you know. And the fact that these little blue dots are here, meaning they haven't deployed yet. So we're going to deploy it. And then I want to open this window here. This is the debug window. So anything that this says is going to show up here. Okay, so this is how we can test stuff. And there's your timestamp in whatever format that timestamp's coming. All right. So,
Since they invented Linux or Unix.
oh, thank you. Somebody's going to know the answer to everything that I do today. I'm going to do it wrong.
December 31st, 1967.
What'd you say about that?
Number of seconds since then. Let's see.
First second since they invented.
Yeah.
Which is gonna roll over in, how many years?
Yeah.
That's the next Y2K.
Y2K, right?
That's the next Y2K.
It'll be
problem.
just as bad as the last Y2K, won't it?
Yeah.
It's another non-event. Okay, so that's really the simplest program. Let's move up from that. Number one, this is a delete, so this just basically clears the debug. Okay. This one, I want to send a what's your frequency command to the radio, and I want it to give me back the frequency. So what are we starting with? Well, we're starting with a payload. Again, we don't care that it's payload because there's always going to be payload. And we're sending an F command to the radio. But remember, when I was doing that in PuTTY, I didn't just send F. I sent F, enter. Okay? So you need that enter. You need that carriage return line feed, whatever it is. And that's a \n, not a /n, a \n. Okay, the one over the enter key, not the one below the question mark. That's a new line character, and just stick that in your memory because that's the way you end the command.
So that's all ham library commands?
Yeah. Yeah, seems like it.
So how's it stopping that?
It doesn't yet. It doesn't yet. That's the next step. All we've done now is we've said, take something called message payload and send it to F and set it to F. And here I could put what I wanted this to be called. Let's call this Ask Creek, and I'll change this. And now that changed to Ask Creek. So you can document what the thing is. Here's where we set it to a radio. This is a TCP request. And I basically take this thing and I drag it and I drop it here. And I drag a line over to it just like I did here. So now we're taking what we set here and feeding it into here. Well, what does this say? You can kind of tell what it's set to. TCP 192.168.50.63:4532. That's the port for Hamlib running on this computer, right? Because we just checked that out. But let's see how this is set up. Okay. So here we've set up properties of the IP address and the port. And we wanted to return a string, okay, a set of characters, and close when the character we received is \n. Okay. We can also have it wait a fixed amount of time after a certain number of characters, never come back. We got these other options in there. It took me a little while to figure this stuff out to make this one work. Okay. And there's the name that I could put here if I could have this say query radio, and then this gray box will say query radio. Okay. But once you set up this connection, you can use it over and over again. I only defined this thing once and all the nodes I'm going to show you. Okay, so this is how we're sending this to this radio. Okay, everybody okay with that? All
So
right.
it just assumes the line that you're connecting.
Yeah, the default is the payload, right. Thank you for pointing that out. Okay, and then it's just going to a debug, which says output the payload to the debug window. Right, there's a debug, and we could give it a name if we wanted to, but I didn't because we're just screwing around here. And now, if this works, Oh, I changed the name here, so I got to deploy it again. See the little blue dot? So I got to deploy it again, and now it'll work. And if I hit this button,
So what did the dot mean?
the dot means I haven't deployed it yet. It means I made a change, but I haven't compiled the program. That's the way I think of it. I don't know whether it's compiled or not, but that's what it is.
That's reasonable.
And what it came out is 147.179.300, which is what the radio set to. So now we got a program where we can ask the radio using Hamlib, what frequency are you set to? And it will come back and tell us. Okay. Everybody comfortable with that? All right. So that's kind of the first step. So I could get complicated, or I could show you how to go to it the dashboard way. And I think I decided to show you the dashboard way. So let's do something a little different here. Okay. What I did here is, this is a different kind of a node. This is a dashboard node. These are down here. Now, dashboard nodes are not included by default in Node Red. Okay, so don't go looking for them after you do your install, because you won't find them. What you have to do is go over here, manage palette, and install. And this is where you can search for nodes that do stuff. And the guys who do development on this stuff have got nodes for everything. Everything. If I typed in Flex, there's a whole bunch of dash nodes for Flex Radio that would talk directly to the Flex API, John, right? Okay. A lot of this stuff's already done. Okay. So if you're looking for something that you want to figure out how to do, and it's complicated, somebody might have already done it. See if somebody already wrote a node to do what you want to do.
It looks like there's a lot of libraries for like smart home integration.
Right.
I mean, there's a lot of stuff out there.
Right. The Amazon switches, probably Alexa devices.
Yeah, you could send
They
Amazon
probably have-
notifications. It's pretty neat.
Yeah. Now, one library that's in there I'm not going to use on my computer, but I'm going to use on my Pi, is a Raspberry Pi library. I can't show you it here, but I can show you it here. And what it does, it will say, set one of these pins high or low. Turn it on or turn it off. And when this relay board's on here, it's initiating the relay. So that's what I'm using to switch these relays here. Okay, and that's what I'm using to control an external device. That's a big deal. That's why using a Pi works really well. If you're building a sequencer, if you're building an antenna switch, if you're building like the satellite switches here, you can have it set these pins on and off, which control these relays, which now you can hook up. I got these hooked up to 12-volt relays in the other end, that are hooked up to antenna relays.
Yeah, that relay board, is that something, that's inexpensive one that you.
Like probably $40.
Or you-
Yeah, and the Pis are supposed to start being available at the end of this month.
Yeah.
For,
Pepperoni actually has high floors and stuff.
okay,
What are they charging now?
I didn't look.
but usually they're like $30 or $40
They got
or something like that. So
2 gig, 4 gig.
yeah, and
sometimes Micro Center will have a
I
sale.
got the
and
lip
you can really get
potato,
as far as the
and that was
relay
$35.
Yeah.
I'm sorry, $40 on what do you
Yeah.
call it? Amazon?
Yeah.
Versus
Yeah.
$200.
right. And this is the 3 relay board. I've seen 2 relays, I've seen 4s, I've seen 6s, so don't just think that the 3 is the only one that exists. If you want to do something more complicated, and you could always connect a whole separate relay board using wires. This is just real convenient because it sits right on top of the board and lets you do an installation.
And you can actually stack the relay board on top.
You could if you could reprogram the pins, which you probably can. Anyway, I'm getting ahead of myself. Here, I was showing you dashboard. There's dashboard. I've already done this, so I'm not going to do it, but I basically said dashboard. It tells me it's already installed, so it won't install it. But the first time you want to set up a dashboard, you've got to install the dashboard nodes. Okay. And that gives you this whole list of dashboard nodes. The light blue ones are input, the dark blue ones are output. You even have an audio out node where you could say, hello, John, and it will come back and actually through your speaker say, hello, John. You can have it give you audio output if you wanted to. So now the cool thing about this is this is what the dashboard looks like. Okay, I've gone to get to Node Red, which I didn't show you. The Node Web, you access Node Red through a web interface, and the address of the web interface is the IP address of the computer that it's on, which in this case is localhost. The Node Red's installed on this computer, and the port address is 1880. It's always 1880. Remember 1880. That's how you get to Node Red. Okay. Once I take one of these dashboard nodes and drag it onto the dashboard here, it creates this web page, which is localhost 1880/UI. Remember that one too. It just creates this. I didn't have to say, create a web page, put this thing in a web page, make it blue. All I did is drag this thing from here to there, and then bang, there's a web page out there. It couldn't be any simpler than that. Okay, so you don't have to be a web designer. This thing just shows up. /UI, user interface. Okay, let's see if this works. So now,
Did you do any additional configuration of that node, or is it just?
no, I just what did I do? I took the default initially, Len, but I later had to change it, and I'll show you why. Because I've got a bunch of different examples I'm going to show, and I wanted them to show up on different tabs of the dashboard, because otherwise it'd be confusing. So I've got flow 3, flow 4, flow 5, and stuff like that. And in each of the flows, I had to tell it what tab to go on. Okay, and I did that simply to make it easier for you guys to see what the hell I'm doing. So I did have to, in this case, tell that this on the next page, what tab to go to. Normally, you probably want everything on the same tab, so you don't have to worry about it. You're building out a dashboard; everything's going to be on the same page, so you wouldn't have to do that. But I did have to do it for this example. Okay, but thank you for the question. So all I've done here is say take message payload and display it. And so let's do that. And there you go. Just showed up. Okay, I initiated the
So if you put like a repeat in there.
let's
you
do
could
it.
actually watch
Let's
change.
do it, Mike. Let's do it. In fact, there's something else I'm going to show you. Think about what's going to happen if I put a repeat every second. It's going to output every second, isn't it? Regardless of whether the frequency changes or not. So let's go in here and let's do a repeat every second. Done. Deploy. Close.
There you go. Far out, dude.
You see how easy that was? That's freaking cool. And all it is like 3 commands here. And if I unplugged this and I plugged it into the 847 and I ran Hamlib with a different node, it'd work on that. And if I plugged in my 7100 from my car, it'd work on that. It's completely computer agnostic or rig agnostic. Okay, so let's turn this off, or it's going to keep doing that.
It automatically figures out the code that you need for the other radio.
Yeah,
Well,
yeah, that's what Hamlet does.
Yeah.
Go ahead, John.
I mean, you have to tell Hamlib which radio it's talking to.
And we did that here, right? Dash M 1035 was the 991. That's where we did it. Okay. So yeah, this stuff would work with any radio. We could plug it into that radio in there.
It'll
All
work with SDRs.
Yes, it does work with an SDR. Okay,
Now, is Hamlib required in order to use?
Yes.
Hamlet's required because it's doing all the underlying changes.
Today I are.
No, I
But like-
mean, this
what?
program, what's it called? Node Red.
Engineer.
No
So
Red
it-
talks to Hamlet, so we're doing.
So it can it talk to something else? Or is it specifically a shorthand,
Let me-
convenient way?
Let me answer John's question, then let me answer Mike's question. So John said, is Node Red specific to Hamlet? The answer is no. It's used for all sorts of stuff. For example, I wrote a Node Red program that reads the power monitor, the TED power monitor over there, reads it every minute, then writes it into an influx database that we can read from Grafana so we can tell how much power we're using on an ongoing basis. I also found one online with a node that I found online that will go to, what's the network speed website? Speedtest.net. Every hour, go run your speed test, and then take it out and then record it. So you can monitor your network speed over time. So there you've got a node that's reading from speed test website. It's got nothing to do with ham radio. Okay. So that's John's question. Mike's question was, does it work with an SDR radio? The answer is yes. Because an SDR radio, an SDR play looks like you can with 2000. And you're gonna set up a
Is that
COM
right?
port. Yeah.
Wow.
You're gonna set up a COM port that looks like that, and you're going to set it up in SDR
And
Play.
SDR, which looks like
SDR Play.
The the little.
Yeah,
SDR.
the little SDR radios we use
Oh,
for receiving. So yeah, I mean, if you don't want to bring your big honking radio like this, you just do it with your SDR. I just wanted to bring the radio out so I can
Sure.
let people see what all this stuff looks like. So, but yeah, you could do it with an SDR, and you could do it if you're on your satellite station. You could have your SDR running on one port and this thing running on another port, and you could have them talking back and forth to each other. In fact, you can do the frequency translation if you wanted to. You could have your own little Doppler shift
Yeah.
program
yeah.
if you're really. Okay, so so the thing I wanted to show you here is just you bring this thing on here, and bango, it shows up there. So let's do something a little bit different. What am I doing here? I wanted to read the frequency, and I wanted to output the frequency, and then this is basically an if statement. Okay, this is a switch node. This is switch. Okay, if I drag this in here, pull a line to it. By the way, note that I can output the different things here. I'm taking the output of this command and I'm dumping it to the website. And I'm also dumping it to a debug node. And I'm also taking it here. Okay, so that would be like a whole bunch of go-to statements, except it's real easy. And you can see them right here, which is another reason I think this is really, really cool. So what I'm doing here is I'm going to say, okay, radio, tell me what the frequency is. And we know how to do that because we did that on the last page. And then there's 3 outputs here. If the frequency is between 144 and 148, okay, which is 2 meters, output to output number 1. If it's on 430 to 450, output's number 2. Otherwise, output's number 3. That's all I've done here. Well, what does it mean to output number 1, output number 2, number 3? You got 3 outputs here, right? So whatever I connect to here happens if it's on 2 meters. And whatever is I connect to here happens, you can even see it's hovering there. If it's between 430 and 450, it'll go to here. And if it's not, this is a situation I had with the radio in the other room. It wasn't always reading the frequency correctly. It would sometimes chop off the frequency. So if the frequency coming from the radio was 146,500, sometimes it would return the frequency as 6,500. I don't know why, and I couldn't make it stop because I'm not that smart. Okay, but what I wanted it to do is, if we're working satellites, it's got to either be 2 meters or 440. If it gives me a frequency that's not one of those things, go back and read the frequency again. And keep doing that until you give me a frequency that's between 2 meters and 440. So that's what's happening here. If it's not between 2 meters and 440, go back and read it again because you made a mistake. Okay. Well, what happens? What am I gonna do if it's on 2 meters? This is a change node. You just take this thing, drag it there. What does it do? It sets message payload to the value of 2 meters. A text field that says 2 meters. What does this do? It sets a text field that says 70 centimeters. And then what does it do there? It outputs it to a field on the website, right? So let's run this thing. And actually, I think we need to run this, keep running it. Okay.
It's gonna read it on that radio there.
Well, what I need somebody to do, there's a band switch there.
Yeah.
All right, so I'm going to change this
You want me
to run every second. Hang on a minute. Every second. Done. Deploy. Close. And then this should be flow 3, I think. And what's the free?
Okay, it's 148.100.
Okay.
We change the band.
Yeah, change band.
They didn't. Oh, okay. Let's see what band. I will try something that doesn't
No,
follow
I
the
want you
logic.
to, it's not showing up correctly. So
Okay, so I selected something that's on 28 megahertz, so
Yeah.
it shouldn't select anything.
right. No, you got to be on 2 meters between whatever I said it was.
Let's see now.
It's got to be between 144 and 148.
Okay, 144. That's 148.
Go down below 100.
Go down, yeah,
Spin the dial.
spin the dial down below.
Other way. Keep
Down to
going.
1.7.
I'm sorry, the other way.
John, when you set that as to repeat every second, you still have to initiate it the first time, or does it?
Good question. Maybe I didn't do that. And maybe I haven't deployed it yet. Should still be working.
Okay, well, now our frequency is 147.971.
Let's give me a second. Sending this. Okay, all right, let's go back here and see what's going on. So maybe I can show you some debugging. First thing I need to do is make sure that I'm not repeating anything over and over again. Okay, it's giving back an RPT0, which means,
Expand that, something like that.
well, there it goes. It should be reporting now.
There we go.
It just had a whole bunch of failures from another node in here. So now flick it up to 440.
Okay. Now, unfortunately, it doesn't seem to have a. Oh yeah, 430,
There you go.
There you go.
438.
Wow.
There you go. Okay.
Wow.
So, so my purpose here was to show you how a switch works. All right, how you can test for different things. So that's what we do here. This is literally the code that we use in there, except instead of just going here, I'll show it to you. Maybe we'll take a break in another 20 minutes. I gotta hook this thing back up before you can show you what the
When you
nodes look like.
specify a particular radio, does it automatically accommodate buttons on that radio? For example, I got split. Okay. Is there a in
So
other words, is something that duplicate? In other words, I've got my little thing here, and I want to go to split operation, and I tap something
Okay.
to get it to actually do that switch.
All right, so my understanding would be you've got VFOA set to one and VFOB2 set to another. There are commands you can say which VFO do you want to use. And this is defaulting to VFOA. But I could set, I believe, I haven't tested it because I haven't needed to, I could say go to VFOB and then it would read whatever VFOB is. I don't use multiple
So when
VFOs.
you define a radio, you're actually just defining what list of cat commands are compatible for that radio that you'd be able to use. It doesn't actually
Well,
track to a
there is,
button,
there
right?
is a cat command for the split mode.
Yeah, so
Right,
then,
right, but that's that's built into Hamlib.
okay.
In other words, we assume that Hamlib knows for each radio all of the cat commands that
Okay.
that radio should understand. We assume that because that's the whole
Yeah,
purpose
so
of
it's not necessarily a button, it's just whatever the radio, it understands.
it doesn't know how the radio got the it could, I mean, look, this radio could got a frequency but by clicking the mode button. You could get a frequency from dialing. You could also get a frequency from an external source,
Yeah,
FT8, telling it what frequency to go to.
right, and FT8 can also switch to the split mode. So
In which
there has
case-
to be, it's probably Rick
It's
under
using
Rick
command,
control.
the cat command.
It's probably a
Right.
Rick control.
Right, it's recontrol supports whatever cat commands that radio supports.
Okay, so
So that's why you have to tell it which radio you have, so it knows which cat commands are valid for that radio.
Exactly.
So it doesn't know buttons, it doesn't know anything, it only knows cat commands.
Yeah, and there are some commands that some radios support and others don't. For example, one I'm interested in is reading the S meter. Because I'd like to do the thing I was talking about earlier, which is set up a program that would rotate the antenna and then take an S meter reading and then change the frequency and rotate the antenna and do that over a week and figure out where the noise sources are at UHF and PHF. Okay, but I have to be able to read the S meter for that, and I don't know whether I can do it on this radio.
and each radio may have a different way
Exactly.
of doing it,
Well, not a different way of doing it. It knows if
different
there's
way of accessing it.
what I'm talking about, each radio may have the capacity to do it or not do it.
Yeah.
Okay, I don't know whether some radio must because I've seen it,
I think
documentation for
I have an ICOM 706 and I think that's capable,
it.
that
Okay,
particular radio.
so what I think would happen is in this radio, for example, if there was a command that said read the S meter, it would probably come back with an error.
991 does, but I use FL rig on my 991, and the S meter is on. rig.
Okay, so
Radio should have.
So let's take a dumber radio. I think if I were using a dumber radio, I think if I said what's your S meter reading to that dumber radio, it would come back with an RPT0 error saying basically this radio doesn't support that command. So that's what I think would happen.
Ground control
Okay.
the major town.
So what I wanted to show you here was the switch. Okay, and hopefully that makes sense. The next one, let me make sure this is turned off. And I want to see if the debug messages stop. Because I think what happened is I've got some other node somewhere that's filling up the output path with error messages. And that's why it didn't come in right away. I think that I'll clear it. Right, there's nothing else running. There's nothing else creating debug. So we talked about getting data from the radio. This is putting data into the radio. And the easiest way that I've found to do that, I'm sure there's a way that you can type a number in, and set the frequency. I'm just too lazy to figure that out. There is a web input for text input. And that's probably what you would use, and then you'd need to use a function which I haven't looked up to convert the text input to a frequency input. So what I decided to do instead is a slider. Okay, so here, and I'll show you what the dashboard looks like. There's the slider. And you slide this thing, it'll give you the frequency. And then the mode, I just created a pull down. So let me show you how we implemented that, and then I'll show you how it works. So the frequency slider, this is the first time we're not using an eject node. This frequency slider is simply a slider. And I grabbed slider from here and dragged it in there. And what does that do? Well, what did I have to change? Not much. I made the minimum the 144,000, and I think there's 3 more zeros there. The 148,000 with a step of 100, and I wanted to output continuously while I'm sliding. So I wanted to keep going there.
Is there a way to dynamically populate step?
I don't know. I'll bet you there is, Mike, and I can see where you'd want to do that because you want to have a band switch, right? What I'd like to do, which is what you're trying to get to, is I'd like to have a pull down that says, 2 meters, 70 centimeters, 6 meters, and have these things dynamically change depending on what band. Because I don't want to have a slider that goes from 50 megahertz up to 400 megahertz because it's going to be too damn wide. All right. And so there's that. And then okay, so here, this thing is sending me the frequency, just the frequency. Well, what does the set frequency command look like? And when I'm talking to Hamlib, it's not just the frequency. It begins with an uppercase F, followed by space, followed by the frequency, followed by \n. That's the way the command is formatted.
/ what?
N.
New line.
New line character.
Oh.
New line character. Okay. That's the way we've always sent a frequency command, right? So we got to create that because all we're getting out of this is the frequency. Okay. So this is a function command, and this is the only place you really have to write program. Okay. And this is basically saying message payload equals F space plus the incoming message payload plus \n. Okay. It's
Is that JavaScript?
I don't know what it is. I just know it works.
Who cares? It does it.
Well, no, when you have an empty function box, I mean, there's probably a ton of stuff that you can do in there. If you
Absolutely. Absolutely. I mean, I've seen examples of very complex code in here. But that's what you're trying to avoid in Node-RED is complex code. I want to be able to connect little boxes together so I can see them. But in this case, there were no little boxes that I could find that would easily do this. So I did actually have to write this code. But you can see what this is doing, right? It's taking the number that came out of the slider, sticking an F in front of it, sticking a \n after it, and then pushing that out the S end up. Okay.
But your output is always just one line in your web page. You can't get multiple going down and it changes over time.
You can. And I can output multiple things from this box too, if I wanted to. And I'll show you that in the next page, because I actually wanted to show that.
You probably do that with a timestamp saying, hey, I did this, it was on this frequency at this time.
Oh, sure.
Frequency at this time.
Oh, yeah. Yeah, we could do that. The next command I'm doing basically is setting the frequency and mode out of the same command. So 2 different fields. I think hopefully that'll show you what you want. And this, why doesn't this go anywhere? This is bugging me because I'm not sure why this works, but I know it did a week ago. So let's go to, so this is showing the frequency. Oh, okay, I'm sorry. This is letting you pick the frequency from the slider. This is going to display that frequency underneath, and this is going to set the radio to it. And we don't need an output from the radio because we're just telling the radio to set the frequency. I was wondering why there's nothing at the back end of this, and the answer is because we're not asking it, we're telling it. And then the same thing here. Now this is a selection box. It's a pull down.
hold on, yeah, there's buttons, sliders, hold on.
Yeah. Well, all of this stuff here, drop down switch, slider, numeric, text, date picker, color picker, form. These are all inputs. I only use like 3 of them, but they're all here. So this is basically going to give us a pull down with a label of mode. And 2 things basically. One is, what do you want the pull down to say? And what do you want the output to be? And I think the first one is, what do you want the output to be? So the screen is going to give me an option for FM space data, but what it's going to output is FM-D, which I think is what this radio wants as the mode to set it to the FM data mode. Everybody okay? Okay. So then we're going to set format a mode command the same way we formatted the frequency command. M space plus whatever I've selected here. And the mode command needs, I think, the passband after it. I just know that it needs this. I'm not even quite sure what it is. But 2400/\n, and that's the end of the command. And so
Those tabs up top, those are events.
So where was I?
Where it says setup, on start, on message,
Where are you, Mike?
right above line 1.
Oh, I never noticed that.
They
This
look
is
like they're events.
Yeah, I think you're right. So on message means when you get a message.
Okay.
Okay. This is probably setup commands, setting variable names and things
So
like
that's
that.
just a dot that you can select. You can select any of those, maybe any or all of them by just putting a dot in there.
No, this is, so this would be when this thing starts, which would be before you get a message.
Those are all methods.
This is whenever you get, yeah. So now you're getting into programming, which is something that Mike's obviously better at than I am, and I didn't need to know to be able to do this. So let's see how this works. So this should be flow 4. See? So I'm moving the slider, and it's actually, and it should be changing the frequency on the radio, right?
Yeah.
Changing the frequency on the radio, and the mode should be changing also.
And the neat thing about this is you do this remote.
I see. What's the
Radio.
mode?
Doesn't matter where I am.
Doesn't matter where you're at.
You know,
Do it across the network.
Yeah.
Yeah.
It doesn't
That's
matter
the
where
power of it.
Well, you
Change the mode. I don't know where the mode display is.
it's up in
It
like
did-
up in the
yeah.
corner, isn't
It
it?
did
Somewhere?
change something.
Oh yeah, right up here. Yeah, okay. There's a little
Yeah. And if there's
square there and stuff. USB.
Okay. Again, you saw how easy it was to create this web page. All it did was drag these things onto the screen.
So you're just a remote control operator. Never associated.
Yeah. Well, when we haven't really built too much smarts into this. When I get a chance to show you the code on this thing, which I've got to take back and hook up.
Have you
Took
tried
some
to
real
look at the
steps.
dashboard on your phone? See if it formats on your phone?
No, but you feel free. It go to whatever the IP address here was, which was
Might have a lock.
No, it's not set.
It was 192.
yeah, I don't know whether John, are they going to be able to access a web page on my computer? Probably not.
Well, it's not,
Yeah.
depends on how you set up your computer.
Yeah.
Do you have that set as a
Public.
trusted network, or
Shit, give it a try.
if you want to go, if you want to go look at one,
Oh yeah, the system monitor. .161, I think, is the system monitor. Try that. .161 : well, let's do it. One. Yeah, here's there's the system monitor, which is a Pi in the other room. And
192.0.0.161.
192.168.50.61 colon 1880. And
Sorry,
the
what was that
UI
number
would be
again?
/UI.
What was the number again? 192 what?
It's 192.168.50, which is the subnet for the clubhouse.61 colon 1880. Yeah, so this is a Pi and cabinet in there. This is one of the early satellite controlling things. This is the power monitor, which is basically reading the power monitor, doing some changes, taking apart the XML message, and then dumping it into an influx database. So this is basically what's reading the power monitor and recording every second what the power consumption is on there, and it's dumping it into a database that we can read. And I'll show you that if you're interested.
Is that a palette that you had to put on for influx database? Node-RED?
Yes.
Okay.
Thank you. Yeah, I had to say, storage.
Oh, okay.
Influx in, influx out. So basically what influx is it's a database that's set up to store events. So it'll automatically tag everything with a date and time. And what we're using it for is to record what the power meter says. And then to display it, I don't want to get into this too much, but 192.168.50.61 colon 3000. Power consumption, that. It's basically reading the power meter and giving us the ability to do that. That's what that Node-RED script does. Okay, it dumps it into an influx database, and then we can access that database from Grafana. Influx and Grafana are a topic for another day. Okay, if you're really interested, I can show you how to record events and then look at them here. That's not a topic for today. So let me get back to what I was talking about. So that's, how you can take an input from the web page. That's what I'm talking about. This is a control panel and not a dashboard. And you can control the radio with it. And then the last thing I wanted to show you before I get into this is let's do combinations. So let's suppose that you're a net guy and you want to work a whole bunch of different nets. Okay. And in particular, you want to be able to work our 2-meter net or our 10-meter net or a rooster net on 75 meters. I mean, it's never my desire to go to a net where the qualification is to be able to crow like a rooster. Okay? I've just never been interested in that. Sorry, John's probably a member of it, but so
It's not legitimate ham radio either.
well, anyway.
The rooster net?
Oh, come on. All right.
That goes way back.
My
man.
point is that we need to change the frequency and we need to change the mode. Right? And so let's go look at this. Again, we've got a pull down box there, 2-meter, 10-meter, and we're just outputting a 210 and a 3. Okay, because I don't need to have an output rooster and then I've got to see what it's set to rooster. So we're outputting 210 and 3. And we're putting it into here saying if it's 210 or 3, go to 1, 2, or 3, right? It's the same thing we did before. And what do? Okay, here's something a little different. We're sending message payload to 147.18, which is the frequency for the rig. But I also created another variable called message mode. And I'm setting that to FM. because it's the 2 meter, it's a 2 meter FM net. So the point of doing this is I can set multiple variables in the same command. I'm setting a frequency and a mode. I don't have to have two different steps here. Originally, I was going to do that. I'd have one of these to set frequency and then it, connect it to another one that set the mode. But I can do them both at the same time here. So here I'm setting 2 meters and FM. Here I'm setting 10 meters. There's 10 meter, and that's also FM.
That's
Right?
unlimited, right? You can set as many attributes as you want.
Oh, sure.
Okay.
And here, the 3990 at 75 meters and LSB. And while I'm here, let me show you what these options are. Let's add another one. Set it. Actually, this is not what I want to do here. Sorry, I'm going to show you. Yes, that was what I want to do. Okay, so you see what we did here? We basically have defined each net in this. Well, I had to go look up what the frequency of each of these nets was. Okay, and then we can just dump them into a command to set the frequency. I've got each of these commands are all mapped to here to set the frequency. I don't need 3 separate things to set the frequency. I just take the output of each of these and dump them into here, whichever one you've selected. Okay, so this is taking message payload and putting an F in front of it and a backslash after it. Okay, we already did that. And then I'm sending it to a TCP command to set the frequency. We've already done that. Okay. And then here I'm taking the output of these, which created both the frequency and the mode. I'm going down here, and here I'm taking message.mode and sending it to M plus message mode plus 2400. And I'm going to do something here that we haven't done before, which is there's a function here called delay. You want to set up a sequencer? This is what you need. This is going to delay for a half a second. Why? Because I don't want to send two different commands to the radio at the same time. It's going to get confused. They're going to clobber each other. So what I'm telling the mode command to do is delay a half a second before you send it to the radio, so we don't clobber. Now, thinking about like building a sequencer or something like that, where you want to make sure that your transmitter is kicked in before you apply power to it, stuff like that. There you might need to build a delay in there to make sure you got time for the relay to close. This is how you do it. I wanted to show you that too. So now we can go back to the dashboard to flow 5. And if I select 2 meters, it should be setting 2 meters. Yep. And if I go to the rooster net, note it says rooster. It doesn't have the frequency, it doesn't have the mode or anything. This is a level of abstraction beyond that. All we need to know is the name of the net, because we've already told the program what frequency and mode it's on.
It hasn't changed frequency.
I haven't clicked on it yet.
There you go.
Okay. All right. So, and that's where I'm getting to the fact that if we had rotate control running, we could not to rotate an 80 meter antenna, but suppose it's on 20 meters, we could have it rotate the antenna and turn the amplifier. Okay. So you're creating a level of abstraction here, meaning I know I want to talk to the rooster net, so I'm going to tell it to talk to the rooster net. And the program knows what frequency it's on, and the program knows what mode it is. I don't have to think about that. And that's, I think, some of the value of doing some of this stuff is you don't think about what you want the radio to do. You think about what you want to do and program that into the radio, and then it just does it. So, so that's what I had to show you in terms of this stuff. And if you want to take a couple of minutes, I'll boot this thing up, and then I'll show you a really complicated set of node red instructions.
And at the end, the node red, it actually has a way of laying out a box and putting this stuff in it too, right? In other words,
A more complicated dashboard than this.
Well, a more dashboard.
well, I
that has
mean, you can use it as a, instead of outputting it to a web page, output it to a window that appears on the computer.
Well, isn't that a window to the computer on the computer?
You're creating geo fencing in order to operate different, modes.
So this is the only way that I know it outputs. Okay, and you know, the disadvantage of this is you got to open the page. So if I'm running satellite station, I've got to have this thing open if I want to be able to control it. Although most of the time I don't care.
I think if you want something fancier than the web page, you're already gonna know how to program it. You won't need no.
No,
It
Okay,
could be.
here's the reason I'm asking. I don't know if it was a year ago, sometime in the last 2 years, there was a article at QST talking
Plug
about
this
Node-RED for the very first time. And they had Windows with the information.
Okay.
So obviously it has the capability of producing a window.
You would have to be on that machine that's running Node-RED though, for that to happen.
You talking like graphical interface.
Yeah.
Yeah.
Yeah, so it's just a pretty output screen to be able to change any numbers instead of having to go into the box.
And
That's
that's probably,
Sophisticated with it.
That's what people want.
But if you go on
No,
YouTube, there's
no,
a guy who's really excellent with that. He's graphical on his screen is unbelievable. I used to work two-way rated commercial, and they started with these graphical user interface screens probably 20 years ago with remote control devices for commercial radio. And you actually pushed on a screen, not mechanical buttons to change mechanical controls. So there is a fellow who's on YouTube. He is top notch with that screen on there, depicting everything. Here it is right here.
Yeah,
That's
That's where you go.
that's created in Node-RED.
Yeah.
So you can make the dashboard really
This is
pretty.
unbelievable.
yeah, it's cool.
Yeah.
We used to use DC control to
is that the
control
same palette
transmitter.
that you're using for your
I don't
dashboard?
know. I don't know. I mean, but this
Well,
is,
you've got to put in a lot of other widgets. And,
Yeah.
Yeah, I would
but
imagine.
but it's basically the same I mean, his code is going to look like
Oh, yeah.
My code,
No,
just a hell of a lot
Yeah,
more
there's
complicated.
a lot more things there.
It's incredible.
Pretty devices, you see.
Yeah, I mean, he's got different coloring in here. He's got different columns of
We
things.
used to use
You know.
175 volts DC, pump it down telephone wires for miles to control a DC relay at the far end. And then we had currents, plus and minus currents, to control the frequency. You push that button, they change to a different frequency. And my phone was going out checking the DC currents to see if the telephone companies screwed up the DC control lines on the far end. I like going for hours on that. And then we went to tone remote. That was fun. DTMF phones, but all different times. That was fun. This is 1,000 years ahead of me. My technology, what I
Say
learned.
1,000.
Well, 999 years. This
50.
is just too cool.
So this is the
Possible now, but not 50 years ago.
This is what runs the satellite antenna switcher. There are several modes that the switcher can be set to. One is a receive only mode, which connects both antennas to the receiver, which is what you need if you're not transmitting. Both antennas connected to the receiver. There's cat mode, which is go look at the transmitter and see what frequency the transmitter is set to and set the antennas to transmit on that band and receive on the other band. And the other is manual mode, which is, let me switch that manually. I can show you that. Show you 192.168.50.78:1880/UI, right? Yeah, there it is. There's the dashboard tool. So, and set it to RX. Can't actually set it to CAT because the radio's not turned on. Actually, I better turn the radio on. And actually, I'm not sure whether Hamlin's left or something, so the dashboard may not be active. And then this manual mode here lets me choose UV, which is UHF up, VHF down, VU, or RX only. So this is basically the dashboard for it. So what we're doing is we're testing for the mode to see if it's RX or MAT. If it contains RX report, that means that there's an error someplace and we'll come back. If it's manual mode, we're going to read what the manual mode switch is set to. I'm going to skip a lot of this stuff. And then if it's set to 2 meters, for example, we're just going to set the message payload to 2 meters. And the control comes in here. This is what I can't do on a PC. If this is set to 2 meters, this is a command I didn't show you before. This is the GPIO pins on the 5. Okay. And these and the GPIO pin 26 controls one of these relays. Okay, it's the physical, it's which of these ports that relay's kicked on.
Is that layout in the library?
Yeah.
Yeah.
No
So you can
Oh,
put
yeah.
that on and off the
Yeah.
thing.
Yeah.
Yeah, oh, it's just a radio button. You pick which pin.
Yeah, I'll show you how you bring the library. I'll show you the library, but this is part of the Raspberry Pi library.
Yeah.
This is controlling external devices. So what I've said is I want whatever I feed to this thing is going to be a 1 or a 0, right? Because it's a binary switch, and I'm going to feed it to port 26. So what does this do? If this is if the node knows it's supposed to go to 2 meters to transfer on 2 meters, either because I've done it manually or because the cat controller's done it, here's the flow. Set message payload to 1. Output on node on pin 26, which kicks the 2 meter relay in. And then what's the next flow? Down to here, set this to 0, and output it on 70 centimeter.
What node type is that? That you're
This is Raspberry Pi GPIO in and out.
Okay.
That's a big deal. That only exists for the Pi, but that's how you control external devices.
Which is why it's good to run Node Red on Pi.
But this is the level of abstraction. Basically, I want it to be on 2 meters. The program decides that this relay needs to be this way and that relay needs to be that way. Set this to 1, feed 1 to that pin, set this to 0, feed 0 to that pin. If it's RX only, it sets 0 to here and 0 to there. Okay, so it does all of that kind of stuff, and there's a lot of logic in here. You can see there's the request frequency again. If it's unknown, it basically takes the output of, if it's 2 meters, you output 1. If it's 70 centimeters, otherwise, you haven't seen it otherwise before. But this is basically if the frequency coming out of the radio is 146,300 and it's giving me 6300. Okay, it's going to hit it otherwise, right? Because it's not between either of these things. What's it going to do? It's going to bump it back into the thing where I'm saying, give me the frequency again. And it's going to keep looping until it gives me a valid frequency. So that's how I fixed that.
So the whole gist is you don't have to write code. You plug and
That's it.
play nodes and
That's it.
here's some switch settings and let her rip.
Yep.
Yeah, and you can see, I mean, I can hover over this. It'll even tell me what the if statement is. So it's real easy to debug. And this starts getting complicated, as you can see.
Is there an abstraction layer where you can take a common function and make a node right out of it? And use it in other places?
So I'm sure there
Like
is,
subroutine?
and I talked about this earlier, but yeah, there is an entire library of nodes, of palettes. They're called nodes here, I think, but it's whatever these things over here are that somebody has programmed. So, for example, there's a library for Flex.
That's I'm asking, can you make a node out of your code?
I don't know.
The function box that you had up earlier, where you were concatenating things.
Right.
That you could put code in there, it looks like, where you have tabs
Right.
that are events.
Yeah. No,
Yeah.
I'm looking at a complex logic.
Well, I think you could put that in here.
Right. So you could write code in here. I've seen these be quite lengthy. So if you need complex logic, you could write it there. But you're saying, can you then reuse that?
Yes.
Is that
Wow.
Python?
As if it were.
I don't know.
Something saying-
He thinks it's
That's what you're
JavaScript.
saying. That's what I'm
Thinks
looking at.
what?
Yeah.
Mike, you think that's
Well,
what?
keep in mind, you can feed it back to the same
You
node.
think that what code?
I look like JavaScript, but I'm not really.
I was
Yeah.
wondering if it's Python.
It could be that too.
I don't know.
I mean, I do see things where it's separate.
Yeah.
It's an object with, and you know,
So then the other thing I did
property.
down here is you could have a situation where the proper antenna is not connected, either because you're in RX, probably because you're in RX only mode, but the transmitter transmits. The transmitter transmits in that mode, there's no antenna connection. So I want to make sure that if the transmitter transmits, I immediately connect an antenna to it. And that can happen for two reasons. Number one, if it's in RX mode. Number two, if I'm working half duplex. Because some of the satellites, like GreenCube or the APRS satellites, are half duplex, where we're transmitting and receiving on the same antenna. But we're receiving on an SDR radio and transmitting on an 847. So we still have to switch that antenna back and forth between two different radios. So here, I'm sending a T command to the radio every 0.1 seconds. And this is basically saying, are you transmitting? Because the transmitter could transmit because somebody made a mistake, somebody picked up a mic, somebody pushed a button, or the GreenCube transmitter, GreenCube program has told the transmitter to send a digital signal. Okay, so the radio can go into transmit because a program has commanded it to. I need to know that. So I'm basically sending a T command, adding a new line after it, and then sending it to the radio. And if I send it a small T, it's going to return, that radio is going to return a 1 or a 0. And a 1 means I'm transmitting, a 0 means I'm not. Trying to remember. Okay, if the transmitter's off, if the radio's not turned on, Hamlib's going to give me an RPRT message, which is an error. It's going to say, you sent a command to me that I can't execute. Well, if I send it a Hamlib command to talk to the radio's not going to turn on. That makes sense. So here I want to basically say, all right, if you got an error, don't do anything. But if we're transmitting, I'm not going to go all the way through this logic. We're basically going to set the radio to whatever satellite mode it was last set to immediately. Okay, and that's what this logic in here does. I won't go through all of it.
So you can make this as convoluted as you want.
Yeah, you know.
So, John, let me ask you a question. You started this.
Mhm.
This is yours, right?
Yeah, I wrote this.
You don't have to start
No.
this file, you just-
No, you don't have to. You don't have
No,
to.
because I can understand it. 3 or 4 nodes. That's easy, right? When we start to get more complex logic and, you start to get confused as you further down the chain, making sure everything's working correctly. Sometimes-
But Mike, if you're going to write it on paper, what are you going to do? You're going to draw like boxes with little lines between them, right? What's that?
Exactly.
That's why I like this stuff.
It's like writing a letter. My wife will write something on a piece of paper, and I'll end up typing it and printing it.
Yeah. Well, and like things like this.
Enter it in, print.
So suppose you're in RX only mode and the thing transmits, and if you're in RX only mode, you've never asked what frequency to transmit on. So, in here, I just wrote some code that basically says, go out there and ask the transmitter what it's set to. even if you're in RX mode, just so I know what I should set that thing to if somebody transmits. And then there's another one in here I wrote where I can't even find it. At midnight, set it back to RX mode. Because if I log in from home or something like that, I'm only receiving. I want both antennas connected to that receiver so I can receive on either band. So if somebody's left it in some different mode, I want to set back to RX mode. So one of the things you could do in that inject node is at a particular time. So at a particular time, I just set it back. So and this interface, I've changed like 4 or 5 times. I started out with 4 options and then decided I didn't need one of them. Well, if we had like buttons here on a box or something like that, and I got 4 of them, now I want 3 of them, you know, what are you going to do? But here, you just take that node off and it disappears from the dashboard.
It does format properly on the phone too.
Does it? Okay. Yeah. So, you know, if you've got permission, you could be running this thing from your phone. You don't even have to have it on the screen.
I'm curious to know if you could set it up to let it be outside your network.
It's a question for John.
Like if there's some sort of user credentials that you can use to access.
Well, you specified a specific port.
Yeah, but
Yeah, there is a specific
but
port
it's,
you would
but it's an
forward it.
internal address. You'd have to forward the port.
Yeah, but I didn't have to log in to look at it.
But you're on the local network.
Exactly.
Yeah, there are ways to
Yeah.
secure the page.
Right, but you
Yeah,
could.
but they're telling you what port to use.
Yeah, but still,
It's an internal.
I
address.
know you have to go through the rigmarole to
you know how many times,
safely.
how many thousands of times a day your router gets scanned for open ports?
Yeah. So I mean, this shows you how, you know, complex it can get, and this was some.
It is JavaScript. I'm looking.
It's JavaScript.
So all the functions are JavaScript.
Oh,
This,
yeah,
this is some testing stuff. I just
yeah.
wrote a little
there's-
thing that
there's
would
JSON
set
files
the rig to
that,
2 meters.
describe the whole.
Oh,
Yeah.
okay.
Okay, so I just set a couple of things in the program where I could set the rig to 2 meters or 70 centimeters, so I didn't have to go pushing buttons on the rig. I could just click this and it set it to 2 meters, click this and it set it to 70 centimeters, click this to transmit, click this to receive. So I didn't even have to be messing around with the rig. I could do it all within here. So this is a more complicated way. Nowhere near as complicated as that, but this is what you can get to, and you can develop it incrementally. I mean, what I wanted to show you.
That's the result of somebody just deciding, hey, I want to make something pretty.
Well, that's true, but look at what we did here. I mean, I did this specifically to show incremental development. You know, we did this and then this and then this and then this.
This is too cool.
Well,
You
in
know.
your opinion, what was the design time differences between your orange box and the one that you're using now? I mean, when it comes to the programming, you just pretty much drug and dropped all this, right?
Yeah, I mean, this 2 things. Number one, this is all written in C because it's an Arduino, and I'm not a good C programmer. I'm a terrible C programmer. It took, you know, months to get this thing out. Plus, we didn't have Hamlib, so we had to parse the Yaesu cat command, which
Wow.
is a pain in the ass.
Wow.
And it still doesn't.
And I think
work
you were
right.
sniffing.
You know.
You were sniffing the comm line for
Well,
frequency.
so the other thing is that, yeah, I didn't talk about this, but we actually had all right. So one of these is the comes from the radio. It's going from the computer to the radio, and there's actually a Y connector with DB9 connectors on it that go into here. So we actually had a cable that connected 3 COM ports together. I didn't talk to you about how we got 3 COM ports talking to each other in the other room. And that's a program called Hub4Com, which is one of the COM0Com library, and it lets us connect 3 COM ports together. That took a week. And then you asked about how long did it take to develop the code. You didn't ask about how long did it take Frank to 3D design and print this box, which we didn't have to do. Okay, because the box I just took this, put a board on it, created a box, you know, 3D printed a box that looks like this, we're done. I mean, this thing's got components in here holding each of these switches. Gorgeous. It took hours. And if you want to change it, you got to start all over again. Here, we just pop them on the board and take it off.
But the
So-
answer why is that's the kind of thing that Frank loves to do.
well, sure, but I love to do this. You know? And I'm
Right.
not Frank. If I did it, it wouldn't look anywhere near this good. If you've never seen anything I've 3D printed,
Oh, I remember what things looked like before the
Yeah.
box.
yeah, and if you had to make this out of metal, you drill a hole. So anyway, I mean, this is why I like this stuff. Rapid prototyping too.
Yeah.
I mean, you can prototype
That's
the
the
thing,
strength.
throw it together, and you can have pages that look like this, which is crap, and clean them up later.
Well, very interesting.
So anyway, any questions on any of this stuff? Because I don't have anything else to present.
I have one question.
Yeah.
Is there a preferred starting point? I mean, do you prefer to start at your goal and work backwards filling in, or do you prefer to start at the beginning and work way to the end?
I've got to start with the simplest things. So I literally started the way I started tonight, which is I ran Hamlib and then I went in with putty to make sure I understood how the commands worked. Okay. And when I understood how the commands worked, then I would go into and write the TCP node for it. So I built this thing literally the way I showed you. I mean, I built out, let's put in a pull down box for these commands and let it control the relays. Then let's add the modes and let's add the logic. Oh shit, this doesn't work. I was having situations when it was feeding me crap frequencies. It's switching the antennas back and forth because it's feeding, so then you got to code for that. The one remaining issue I've got in this is that radio occasionally will, when you ask if it's transmitting, it will occasionally send you a 1 when it's not transmitting. And that means it will switch the relays to transmit when it doesn't need to. And it's annoying. It's not devastating. It would be worse if it was the other way around. But I can't fix that the way I did with the bad frequency. I can't make it wait and see if it sends me 3 1s in a row, because it might really be transmitting and I don't want it transmitting with no antenna,
But you
if I'm
can
waiting to
always
see
check.
whether it's valid.
If you have the SDR indication, not SDR, reflected power, SWR.
I could do something like that, but keep in mind that anything that's happening there
Is happening
with
now.
with an antenna with no antenna connected.
I think Chris was asking you, now that you're experienced with all this, if you were to set up a project, do you start at your goal and work your way downward, or do you work with that goal from the beginning up to the final
latter.
goal?
I can't.
It's gonna be a learning process. So
That's-
you're not gonna be able to start at the end and work really fast
And-
backwards unless you have all that knowledge.
Well, and that's part of it. So how the hell do I do this? Is
Yeah,
there a node out
I
there?
think that's what Chris's
Yeah.
question was.
Well,
Go start at the beginning or go
Learn.
It wasn't though, because you got two things going on. One is what thought process do you have to go through
Yeah.
to create the output, and the other is how do these tools work?
Yeah.
And for me it was both.
Yeah.
Because I had to figure,
Correct.
how do I do a delay? How does the delay? I got a delay. There's got to be a function called delay. So you look up and see there's a function called delay. How does it
Engineering
work?
Forward or reverse engineering.
How does switch work? And part of it was, how does this function work? The other was, how do I solve the problem of it feeding me bad frequency all the time? Well, that's a programming issue. You solve the problem by checking to see if it's in the range. If it's not in the range, you ask it again and you keep asking it again until you get a good one. And I've watched it enough, go through enough cycles that after 4 or 5 times being bad, it would be good. And that's all I need. So I knew that was going to work.
Very
Stuff
cool.
like that. Anyway,
The SD cards, those little SD cards for the Pi. How do you program those things?
You flash them.
How do you flash them?
The
Actually,
best way is
Easiest way.
use the Raspberry Pi imager.
right.
yeah.
But what do you put that stupid thing into? Into the Pi itself?
Yeah.
Oh, no, you
No.
program it on your PC
Yeah.
using a USB adapter. for the
Right.
card.
Oh, okay. I'll have to get one of those.
Yeah, the micro SDs will slide into a standard SD, and a lot of PCs have it.
If your PC doesn't have a slot for it, then you
Yeah,
get
USB.
a USB adapter.
Oh, okay. I'll have to get one of those.
Yeah.
That's cool. Thank you.
Yeah, and that's
Yeah.
basically how you bring a pie to life. Is as John said, you go to the imager and tell it you want to lay down Raspbian on a pie and throw the card in, and when it's done, you throw the card in the pie right there,
Yeah.
and it'll boot.
And sometimes, sometimes you could find images that are completely single use for a certain thing, where all you gotta do is put it in there. You don't have to configure anything. You just turn it on.
Okay.
Yeah, it's going to come up in a minute if it comes up.
I mean, the imager is best because you can actually go in there and edit it before you flash it to put in your Wi-Fi name and your Wi-Fi password and stuff like that. So
Yeah, there's a
it'll
pie image.
come up.
Take a look.
Yeah. Choose the OS, Raspberry Pi, choose a storage. I don't have anything plugged in right now.
Yeah, but if you click on the gear, then you can actually set your Wi-Fi and everything before you burn.
Oh, I didn't know that.
So you can turn on SSH. You can set the
Oh, nice. I didn't know that. Thank you.
yeah. I mean that's
Yeah,
that saves a lot of time.
yeah,
You'll never use a monitor again.
yeah. So, yeah,
Is that for when you go
Keep a
headless?
portable one with you
Just in case.
yeah, we never
But
run these,
it
we never
saves,
run these with a monitor.
Hooking it up to a keyboard and a mouse and a monitor.
Yeah, the only time I've ever hooked it up to a monitor is to do what John showed me I don't need to do anymore. Which is figure out what the IP address is, and put in the Wi-Fi password, which he just showed me you can pre-program there. Yeah, these things are amazing. I mean, you've seen the Pi rack we have at the network.
Yeah.
If you haven't seen the
Yeah,
the Pi rack in the
that's
network
incredible.
cabinet, you need to take a look. We've made them do
Yeah,
all
so-
sorts of stuff.
You can save your flow, or actually, if you
Oh,
you
yeah.
can create a subflow, save it, and then you can drag that into any other
Subflow. Why does that sound like subroutine?
Yeah, and let me show you one other thing that I didn't show you, and that's export. But yeah, how do you back this thing up? Because this is sitting in the Node-RED directory. What you can do is export all flows, download, and it downloads flows.json. And now you got a backup. And you could then you can import it by the same command, or you could move it someplace else. And it ought to be, John, correct me if you think I'm wrong, this ought to be platform agnostic.
It's portable.
Yeah, so I could write this.
It's a JSON file.
So I could write this on a PC and run it on a Pi. The only thing that wouldn't work is if I went the opposite direction.
Well, your GPIOs would.
GPIOs aren't going to work on a
Yeah.
PC.
I think it's
So-
hardware specific.
So, but if you want to back it up or you want to, put it on GitHub or use version control or something, you could do that. You can bet I've got copies of this thing. Trying to create it again.
Is there a print of those GPIOs for the Pi?
Yeah, you can.
You
I
can
have-
find them anywhere.
Well,
In fact,
I'm
some-
curious. Are they
Some of the
standard?
cases color coded right on the case.
Yeah.
Well, I bought the Libre potato, and it's a clone of the Pi, and it has the same amount of GPIOs. I'm just wondering if they configure that as a standard set.
Yeah, so they can use Raspberry Pi hats.
Yeah.
So yeah, they're configured the same.
Is there a difference between the GPIOs and the versions? Five, like
You get one of
the
these.
4, right?
The ones and the two, the ones and the twos are different from the threes and the fours,
Okay.
but it's not
That would
by
just
much.
sit right on here.
the
No way.
3s and 4s, the bigger. And there's more GPIO, but like from pins 1 to whatever, they're the
Far
same.
out.
Oh, okay.
So it's
That was Adafruit,
3s
right?
and 4s are super
Yeah,
set.
what's something like this?
The one that is 1s and 2s.
Okay. Now, what about the zero?
I don't know about zero. Never used.
You can take
What are the power supplies?
take this and just
voltages?
print it off.
3 and
Work
3
on
and
both
5
0
volts.
and 5.3.
Oh, do that?
It's
Okay.
a
3 and 5 volts.
no, this is fine. It's a mini D,
So they're essentially the same.
or it's a USB-C
USB-C.
for the 5.4 uses USB-C.
Yeah.
I plugged the
Now, if you hook up a
fan
separate
of those
power
two,
supply, you're
ports.
hooking up a separate plus 5.
I'm not right.
Yeah,
It was one.
In other words,
It uses a wall.
it can't
ran-
deal with voltage.
Ran the 5 volts for the little fan and case
No, use a wall.
off of that. That's the
Yeah, yeah,
Looks like the
3 volt.
same.
You can pick up 5 volts off of it.
5 volt.
You just gotta make sure your power supply can handle.
Right. Yeah, one of the big issues we had with pies was when we started hanging a lot of stuff off them, like for the weather station. We had sensors and all sorts of stuff on that. And the power supply couldn't handle it. It'd start rebooting itself randomly, and we had to make sure we were feeding it with, I think, a 3 amp supply. Same thing with the GOES receiver. We've got an SDR receiver and a preamp that we're feeding with bias T data, and we had to make sure that we were feeding the Pi enough current so that it can run all those peripheral devices. With something like this, you don't. But if you're hanging a bunch of stuff off, like SDR radios or sensors and stuff,
Are you running the decoder in the same Pi?
Yes.
For that? Okay.
yes, that's still not working, by the way. Like, we need to get together and get all the brain trusts together because my brain is exhausted.
I just got my book. So.
Okay, well, maybe you need to come help us.
Yeah. Yeah, I don't know if the preamp went bad over the year it was off.
I tested all of that too.
Just don't seem to be getting
Yeah,
enough signal.
right.
I know the day that smoke hit us, you weren't getting the signal.
Yeah.
Yeah, well, I mean, I've been beating my head against the wall.
What kind of bit score were you getting?
500 volts,
Okay.
and it was lower than that. Anyway, I don't want to tell you to do.
Yeah.
But yeah, you can, there's all sorts of things that'll give you the pinouts. Little things you can put over the pins that'll label them for you. But anything else, guys? All right. Well, thanks everybody for coming.
Thank you.
Hang
Thank you,
around,
guys.
talk about whatever you want to talk about.